Okay, now we're going to work through example 2 from your notes, and we're going to continue with conversions and using dimensional analysis because that's extremely important in AP. Now, these examples, I'm not just going to ask you to calculate moles or grams, but this will be only one step in a much larger problem. So you're still going to have to make sure that you know how to do these types of conversions, just because it's going to be assumed that you already know how to do this. So what we're going to do is we're going to go through example 2, which says how many moles of water are in 15.4 grams of water. And so what I already did was circled what we're trying to find. The problem is asking us to find moles. So I circled moles and I underlined our given. So we're trying to find moles, we're given 15.4 grams of water. Now whenever you're given grams of something, you're going to have to find the molar mass, okay? Because you always want to convert to moles. In this case, that's what the problem is asking us to do. So what I did is I found the molar mass of water. Now you might already have this memorized, but you want to make sure that you have it memorized in terms of more significant figures. Significant figures are extremely important. So what I did is I said, well, in water, H2O, we have 2 H's and 1 O. So I took 2 times the mass of hydrogen from our periodic table plus 1 times the mass of oxygen, and that got us 18.02 grams per mole. Now remember, units for molar mass are always grams per mole, and in this case, the more significant figures for molar mass, the better. So we have grams, we're trying to get to moles, we have the molar mass. So what we need to do next, set up our dimensional analysis or our factor label. We're given 15.4 grams, okay? Times sign fraction bar. Our units always need to cancel. So if I have grams on the top in our given, I'm going to need grams on the bottom. So 15.4 grams of water, we're going from grams of water to moles of water. That's why molar mass comes into play. Molar mass is grams per 1 mole. So in this case, for 1 mole of water, we have 18.02 grams. Multiply across, which means we end up having 15.4 grams divided by 18.02, and we get 0.855 moles of water. Now, notice my answer is given in 3 significant figures because my given is 3 significant figures. So 3 sig figs, I have units, and I have the substance. So 0.855 moles of H2O.